Python Interview Question Series. Part 3, OOP and Problem Solving, Questions 21 to 30. For students, freshers, and Python developers. Object-Oriented Design and DSA Concepts. Let's get started. Part 3, OOP and Problem Solving, Questions 21 to 30. 10 core OOP and DSA interview questions. Focus on inheritance, overriding, complexities, and optimization. Structured explanations with visual tables and code blocks. Let us start with question 21, explain the 4 core OOP concepts. Object-oriented programming organizes code into objects that bundle data and behavior together. There are 4 fundamental pillars. First, encapsulation. This means keeping an object's internal data private and exposing only what is necessary. Think of it like a capsule medicine, the drug inside is protected, you just interact with the outside interface. Second, inheritance. Child classes acquire properties and methods from parent classes, dramatically reducing code duplication. Third, polymorphism, meaning many forms. Different classes can implement methods with the same name, and Python calls the right version based on the actual object type at runtime. Fourth, abstraction. This hides complex internal details and exposes a clean, simple interface. Together, these 4 pillars allow you to model real-world systems in a scalable and maintainable way. Question 22, what is inheritance? Inheritance is the mechanism by which a child class acquires properties and methods from a parent class. Think of it like family genetics. A child naturally inherits traits from their parents but can also develop their own unique characteristics. In the code on screen, we define a parent class animal with a speak method that returns the word sound. Then we create a child class dog that inherits from animal. Dog overrides the speak method to return bark instead. When we instantiate dog and call speak, it uses the overridden version and returns bark. Python is uniquely powerful because it supports single inheritance, multiple inheritance where a class inherits from 2 parents, and multilevel inheritance where classes form a chain. Question 23, what is polymorphism? The word polymorphism literally means many forms. It is the ability of different object types to respond to the same method name, each in their own unique way. Think of a remote control with a power button. The button is the same interface, but a TV, air conditioner, and speaker each respond to it differently. In the code on screen, both cat and dog classes have a speak method. The function make_speak accepts any object and calls speak on it. When you pass a cat, it prints meow. When you pass a dog, it prints bark. The function does not need to know the type in advance. Python determines the correct implementation at runtime. This is what we call duck typing. If an object has the speak method, Python will call it, regardless of its class. Question 24, what is abstraction? Abstraction means hiding the complex internal implementation and exposing only a clean, simple interface. Think of driving a car. You press the accelerator pedal and the car moves. You do not need to understand the fuel injection system or how the engine pistons work internally. You only interact with the simple pedal interface. In Python, we implement abstraction using the ABC module, which stands for Abstract Base Classes. Look at the code on screen. We define device as an abstract class that inherits from ABC. The turn_on method is decorated with abstract method. This is a placeholder. Any concrete class that inherits from device must provide its own implementation of turn_on before it can be instantiated. If it does not, Python raises a type error. Abstract classes themselves cannot be instantiated directly. Question 25, difference between class variables and instance variables. Look at the comparison table carefully. A class variable is defined directly inside the class body, outside any method. It is shared across all instances of the class. Every object references the same memory location for this variable. Think of it like a shared company notice board that every employee reads. An instance variable is defined inside the constructor method using the self keyword. Each object gets its own completely independent copy. Think of it like individual employee notebooks. If you change one person's notebook, nobody else's is affected. Class variables are perfect for shared constants or counters. Instance variables are for data that differs per object. Question 26. Explain method overloading and overriding. Look at the table on screen. Method overloading means having multiple methods with the same name but different parameter signatures within a single class. Python does not natively support overloading like Java does. Instead, we simulate it using default arguments or variable argument lists to handle different calling patterns. Method overriding is different. It occurs across parent and child classes. A child class redefines a method it inherited from the parent using the exact same name and the same parameter list. This changes the behavior for that specific subclass without affecting other subclasses. Overriding is fully and natively supported in Python and is one of the core ways polymorphism is achieved in practice. Question 27. What are stacks and queues? These are fundamental linear data structures used everywhere in computer science. Look at the table on screen. A stack follows the last in first out principle, or LIFO. Think of a stack of plates. The last plate placed on top is the first one removed. Operations are push to add and pop to remove from the top. Python lists and collections.dec both work well for stacks. A queue follows the first in first out principle, or FIFO. Think of people standing in line at a ticket counter. The first person in line gets served first. Collections.dec is the most efficient Python implementation for queues. Stacks are perfect for undo systems, browser history, and expression parsing. Queues are perfect for task scheduling and message processing. Question 28. Explain time complexity with examples. Time complexity tells us how the execution time of an algorithm grows as the input size increases. We express this using big O notation. Let me walk through the 4 most common complexities you must know for interviews. O of 1 is constant time. Dictionary lookups happen in the same time regardless of dictionary size. O of log n is logarithmic time. Binary search is the classic example. It halves the remaining search space on every step. O of n is linear time. A single loop scanning through a list from start to finish is O of n. Look at the code box for this example. O of n squared is quadratic time. 2 nested loops each iterating over the same data is O of n squared. Always evaluate your algorithm's big O before using it with large datasets in production. Question 29. Explain how Python dictionaries work internally. Dictionaries are one of Python's most powerful and frequently used data structures. Internally, they use a hash table. When you add a key-value pair, Python passes the key through a hash function. This function computes a unique integer index. Python then stores the value at that exact index in internal memory. When you retrieve a value, Python hashes the key again, jumps directly to that memory index, and returns the value in essentially constant time. This is why dictionary lookups are O of 1 on average, regardless of how many items are stored. There is one important constraint: keys must be immutable and hashable. Strings, integers, and tuples are valid keys. Lists and other dictionaries are not valid keys because they are mutable. And finally, question 30, how do you optimize slow Python code? First and most importantly, never guess where the bottleneck is. Always profile your code first using Python cprofile module or the Timite utility. Find the actual slow section, then optimize only that section. Next, examine your data structures. If you are checking membership in a list, that is O of n per check. Switch to a set for O of 1 lookup. Then look for unnecessary loops. Can you replace nested Python loops with NumPy vectorized operations? NumPy runs in compiled C code, which can be 10 to 100 times faster. Use built-in Python functions over custom logic wherever possible, because built-ins are also implemented in C. Measure performance before and after every optimization to ensure you actually improve things. Thank you for watching. Subscribe to SHR Trinity for more videos, training programs, live classes, and career guidance. Like and share if this video helped you. Stay tuned for Part 4, Advanced Python. If you are interested in attending our live training sessions or have any inquiries, all our contact details are displayed right here on screen and are also available in the video description below. Feel free to reach out to us. We would love to have you as part of the SHR Trinity learning community.